In our experiment on solutions, in the first part, you're going to be mixing liquids together and determine if they are soluble in each other. In chemistry, the term we're going to use, if your two liquids, when you mix them together, we use the term miscible. If the two liquids, when you mix them together, do not mix, then we call that immiscible. In the second part of the lab today, you're going to look at the solubility of a solid in a liquid. And the solid we're going to be using is iodine. We'll have iodine crystals, and you're going to see if they're more soluble in either acetone or water. The first two solutions that we're going to test if they're soluble in each other are ethanol and water. So we're going to do equal quantities of each. We're going to measure 1 ml of deionized water. I'm using my graduated cylinder for the first one, so I know about what 1 milliliter is when I put it into my test tube. Okay, so I'm doing it so the bottom of the meniscus touches the line at 1 milliliter. So I'm measuring 1 milliliter. Now the exact quantities are not important in this lab. What matters is that we have equal quantities. So I'm going to put my ethanol or ethyl alcohol, same thing. And I want to just make sure that I have an equal quantity. So I can just sort of eyeball it so that it looks about the same quantity of each. And then you're going to go ahead and mix your solution up. And then you'll observe to see if it has 1 layer or 2 layers. So if it looks like that it's completely mixed, we won't see a line separating my 2 layers, then we would say that my solution is miscible. The next two solutions I'm testing are water and acetone. Now the water I've already put in here. So again, I'm going to do the equal quantity, and I'm putting in acetone. One thing that's important when you're doing this lab is to make sure that you start with test tubes that are clean and dry. So if you have something else in your test tube already, that may alter your results. So again, I'm going to mix it up and then determine if we see 2 layers or not to see if it's miscible. The next one we have is water and hexane. Our next two solutions are water and mineral oil. And again, I have the water in these first 4 test tubes already. So mineral oil is also known as paraffin oil. So let's see if water and oil mix. And if you're not sure on some, you can always mix them and then let them sit and come back to them later, since they'll all be labeled, and determine if it formed 2 layers or not. The next sample we have is ethanol and acetone. So for the ethanol series, I've already put those in here as well. So we need to add our acetone to that one. Next we have ethanol and hexane. So the ethanol again is already weighed out there. I'm putting hexane in with this one. have mineral oil and ethanol. For this one, we may want to let it sit for a little bit. See if we can tell if it's forming two layers or not. And for some of these, it may not completely dissolve, but if it partially dissolves, we would call that partially miscible. In between the two, where maybe part of it is dissolving in the other liquid of one solution. Our next sample is acetone and hexane. I've already measured out the 1 milliliter of acetone, so I need to add our hexane to the sample. The next sample we have is acetone and mineral oil. So here's our mineral oil. We'll let this one sit for just a moment. And our last sample we have is hexane and mineral oil. Those bubbles too. For the next part, we're going to determine if iodine crystals are more soluble in acetone or in water. So I have my iodine crystals here. I'm going to take equal size crystals for each of my test tubes. You want to make sure your test tubes are clean and dry and labeled always. So I'm putting an iodine crystal in here, and the iodine crystal that I put into my other test tube, I want to make sure it's of equal size so we can do a comparison here. And you want to make sure you take small crystals. Okay, so I have my iodine crystals of approximately equal size in both my test tubes. Now I'm going to add water to one of the test tubes. So I have some deionized water. I'm going to put in 2 milliliters. That one. And then into my second test tube, I have acetone. And I'm going to put in 2 milliliters of acetone to that test tube. And then we're going to gently shake our test tubes for a minute and determine which one is the iodine more soluble in. So you'll be looking for a color change here. As the iodine crystals dissolve, the color of the solution becomes darker. So you are to compare, is the iodine more soluble in the acetone or in the water, based on the color of your solutions. For part C on our experiment on solution, we're going to be looking at the effect of temperature on the solubility of a solid dissolved in water. The solid we're going to be using here is copper sulfate pentahydrate. What you'll be doing is you'll have 2 test tubes. One will be at room temperature, the other will be heated in a water bath. They will both contain 5 milliliters of deionized water and 10 drops of hydrochloric acid. You'll be adding 0.5 grams of copper sulfate pentahydrate to both the test tubes. You will keep adding it until it no longer dissolves. And then what you're trying to determine is copper sulfate pentahydrate, is it more soluble in room temperature water or in hot water? I am now adding 5 milliliters of DI water to both of my test tubes. And then I'm going to add 10 drops of 6 molar HCl. To each of my test tubes. And then go ahead and mix that. And then we'll be adding the copper sulfate next. I have put a weighing boat on the scale here. You want to go ahead and push the 0 button to tare that, which means we are going to be subtracting the weight of our weighing boat, automatically done by the scale. Now we're going to add 0.5 grams of copper sulfate pentahydrate, these lovely blue crystals. Okay, so I have 0.498 grams, which is close enough to 0.5. We need approximately 0.5 grams. So we'll go ahead and add this to our water. Now we're going to add our copper sulfate pentahydrate into each of our test tubes. The thing that's sort of handy with these weighing boats is you can bend them a little bit to help you get it inside without spilling any. And you can swirl it a little bit to help dissolve it. And we can see it's not dissolving. I'm going to go ahead and put that one in the hot water. Make sure it's completely submerged in your hot water. And then I'm going to add my other 0.5 gram increment of copper sulfate pentahydrate to the one that's at room temperature. Again, we're going to go ahead and try to dissolve that. And we can use a stirring rod to help us. For the one in hot water, and we can stir at room temperature water. This one doesn't seem to be dissolving. But the one in hot water, it just about has dissolved. With enough swirling of my room temperature sample, I eventually got it to dissolve. So I'm going to go ahead and add another 0.5 gram increment of copper sulfate pentahydrate to this. And I will continue to swirl this to see if I can get it dissolved at room temperature. My sample in the hot water has dissolved, so I'm going to add more sample to that one as well. So I have another 0.5 gram increment of copper sulfate, which I add in here. And the one in the hot water, I'm using the stirring rod because I don't want to touch that hot test tube. And I will mix that one around. So the idea here is you're just going to keep adding these 0.5 grams of copper sulfate pentahydrate until your sample will no longer dissolve. And that's the mass that you'll record in your notebook. So both our samples are dissolved again. So now I'm going to go ahead and add the third increment of 0.5 grams to each of our samples. Mix these up again and see if they dissolve. So even with a lot of swirling, I could not quite dissolve all of that solid copper sulfate pentahydrate in the water after increment number 3. So about 1.5 grams is what we were able to dissolve in the water approximately at room temperature water. The one in the boiling water, however, is completely dissolved. So we're going to add increment number 4 to this one. And that one dissolved fairly easily. So we're going to add another one. This would be increment number 5 of our 0.5 grams. You can see that a little bit of it's sort of sticking to the sides. I'm just going to use my stir rod to sort of push down any of that copper sulfate that might be stuck on the sides. You also want to be careful not to spill any of it in the water, because we can't account for that mass when we're trying to determine the mass that actually dissolves in the water. And it looks like number 5 dissolved pretty easily as well. Right, that's number 6. Number 7. Sample down in there. It still looks like it's dissolving. Adding increment number 8. Still dissolving. You have to have patience as a chemist. 9. Might be getting close. Looks like it's getting a little bit harder to dissolve our copper sulfate pentahydrate. We're getting to that point of saturating our solution when you can no longer add any more. I think I just dissolved our last piece. All right, let's try number 10. Must be getting close. Again, number 11. This has to be the magic number. Let's find out if our water can handle any more copper sulfate. Then the physical agitation is also helping to dissolve it. It looks like it has dissolved again. This is number 12. $13. 14. And I think we've gotten to the point where it is no longer dissolving. I see solid stuck at the bottom. Let's make sure we get everything off the side. And our sample is no longer dissolving. We have finally reached the solubility point. We have a very saturated solution here with copper sulfate pentahydrate, and there is solid on the bottom here. If I can take it out, you might be able to see that there is a little bit down here that did not want to dissolve. In part D of our solution experiment, you will be comparing the rate of dissolving a large crystal of copper sulfate pentahydrate in water compared to the same mass of powdered copper sulfate pentahydrate in water. So you'll go ahead and weigh out a mass about the size of a little green pea, and then you'll record that mass. Then you're going to take the powdered copper sulfate and weigh out the same exact mass as you did as your pea-sized crystal here. And then you'll dissolve them both in 5 mL of water and compare which one dissolves faster, the large crystal or the powdered crystals. And then think about why they may dissolve faster. Think about how water dissolves ionic compounds, about those polar ends of the hydrogen and the oxygen, slightly positive, slightly negative, how they're attracted to the ionic compound. The copper is slightly positive, the sulfate is slightly negative. And how, if you have more surface area, may that affect your rate of dissolving your compound. I'm going to go ahead and tare my weighing boat by hitting the 0 key. Once that says 0, I have my crystals of copper sulfate pentahydrate that you can see here. They're very large crystals inside. I'm going to go ahead and take out one of the crystals from here that's about the size of a pea, and I will go ahead and get the mass of that. So this copper sulfate pentahydrate crystal weighs 0.864 grams. I'm going to save that for one of my test tubes to add to water, and then I'm going to get another weighing boat, tare that, and then I'm going to add the same mass as I weighed of my crystal, my 0.864 grams. Now I'm ready to dissolve it in water. Now I'm going to add my copper sulfate pentahydrate to each of the test tubes. So here's my large crystal. And then the other one has the same exact mass, but it is the powdered copper sulfate pentahydrate. And then I'm going to add 5 mL of water to each of those. And then I'm going to swirl them, and you can swirl these for 2 minutes. Now we can compare our two solutions after 2 minutes. The one you can see still has the large crystal in it. The other one is just about dissolved. There's a little bit of small crystals left on the bottom. So you can also compare the color of the solutions, which one is the darker blue, to see which one dissolved faster as well.